make a start. I'll say a few things in general, and then we'll look at least example 1, and then if you want me to, we can look at example 2. First thing to say is that we're going to look at the same problem, and the process of which point we start at the origin, and that we move into the feasible region, and then that we move within the feasible region to find the maximum point. And the points that we go through are exactly the same for the big M as they are for the 2-phase. They're just different ways of making that route. And a lot of the process is the same, but there are some differences. So if looking at the big M, you'll see that it looks very similar. So for the less than or equal to inequalities, we still use the slack variables as before. And in the tableau, the rows will be headed by the first column of each row, or the heading of each row will be the slack for the less than or equal to inequalities. For the greater than or equal to, we'll have slack, or better called surplus or excess variables, and artificial variables, defined in exactly the same way as they were for the 2-phase. The difference is that we won't create an I objective function, and we won't have 2 phases. We'll have just 1 phase, and the artificial variables will stay with us the whole time. But instead, what we'll do is that we'll change the objective function to subtract the artificial variables multiplied by a value m. Okay. Now, the idea is that we will want to make those artificial variables 0, because they can only be 0 or positive. We can't make them negative. So when we make them 0, we'll be in the feasible region. So how can we encourage the simplex method to make the artificial variable 0? What we do is by giving them a multiple in the objective function, which is big enough to encourage the objective function to minimize them above anything else. Yes? And so what we do is we have a value m, which is said to be arbitrarily large, which means it's larger than any other relevant number. So you can think of it as 100, or you can think of it as 1,000,000, it doesn't matter. So it's going to be an arbitrarily large number. And in an exam, they might well ask you, what does m represent in the big M method? And that's your answer. It represents an arbitrarily large positive number.
Is that why it's called bigM, because m is so big?
Yeah, exactly. Yeah. It's a big value. Now, you would really ought to know a bit more than that. And what I'm saying to you is that why we want an arbitrarily large value is that we want to essentially, in the objective function, we want to make A1, A2, all the artificial variables come down to 0. And therefore, we want to subtract m times each of those. So in trying to maximize the objective function, we want to make minus ma1 plus minus ma2, etc., as small as possible. I hope that makes some sense. And what that enables us to do is to essentially apply the simplex method, which was in the basic simplex tableau, was in the 2-phase, applied to the I and then applied to the objective function. Now we just apply it to the objective function, working with big M. So the advantage of the big M is that we don't have to have this I row. The disadvantage is we have to work with algebra. We have to work with an M, which we don't know what the value is. It's just a very large value. Okay, so I'm going to now start looking at this particular rather easy example and hope that you can generalize to the example 2, and then you can generalize when we don't have the graph of the situation. But can you see here, we have the same inequalities, 3x plus 2y less than equal to 15, 2x plus 5y less than equal to 20, y greater than equal to 2, and x greater than equal to 0. So the first two correspond to this line here with a surplus, a slack variable S1. The second one with slack variable S2. And then y greater than equal to 2 corresponds to this line here with a surplus variable S3. When it's positive, we're in the feasible region. And then when we're not in the feasible region, we have the the artificial variable A1 being positive. Okay, so below here, S3 is 0, A1 is positive. On the line, A1 is 0 and S3 is 0. And in the feasible region, A1 is 0 and S3 is positive. Okay, so let's look at the formation. We did this last time, so I'll go through it quickly. So 3x plus 2y less equal to 15 becomes, oh, the same mistake should be 3x plus 2y equals 15. Was copied and pasted. Okay. 2x plus 5y less equal to 20 becomes 2x plus 5y plus s2 equals 20. So those are two slack variables. And then y greater or equal to 2 becomes y minus the surplus variable plus the artificial variable equals 2. Okay. And we also need to rearrange the artificial variable to get it in terms of the other variables, which initially will be 0. So it's useful to have a1 equals 2 minus y plus s3. So now if we look at the objective function equals x plus 3y, in the bigM method, to save us having to have the I row, we're going to manipulate the objective function. So we're going to subtract bigM times each of the artificial variables. So we're going to have the objective function minus m times a1, minus m times a2 if there were an a2, minus m times a3 if there were an a3, and so on. So in this case, we're going to have p equals x plus 3y minus ma1. And so our objective function, when rearranged, would become p minus x minus 3y plus ma1, okay, equals 0. And if we now replace a1 by 2 minus y plus s3, we're going to get p minus x minus 3y plus m times 2 minus y plus s3 equals 0. And then if we keep all the variables on the left-hand side, we're going to get p minus my minus 3y, which collectively is p minus m plus 3y, plus ms3 equals a value of minus 2m. Okay. And remember all the non-negativity requirements that, as always, all the variables, x and y, slack variables, surplus variables, and artificial variables, they all have to be greater than or equal to 0, always in the simplex tableau. So each of the rows should be familiar from last time, but notice we don't have an I row, but we do have a P row, and the P row corresponds to, in some versions of the tableau, you actually have a P column, by the way, and you would have a 1 below that. But in this case, each of the rows corresponds to the constraint.
The P is implied.
Say again, Alex?
The P is implied because then
the P is implied. That's right. Yeah. That's right. So as far as P row is concerned, in this form of the tableau, it's implied. So the equation P minus m plus 3y plus ms3 equals minus 2m is written into this row here. And now we apply the simplex method in the usual way to this. So if we look at which is going to be the pivot column, well, we look at each of the values in the pivot in the P row, not worrying about the value or the theta yet. And so underneath x, we have a value of minus 1. Underneath y, we have a value of minus m plus 3. Under S1, 0. Under S2, 0. Under S3, m. Under A1, 0. And that's it in terms of variables. We look for the negative ones. There are only 2, under x and under y. Under x, we have minus 1. And under y, we have minus m plus 3, where m is a large positive number. So minus m plus 3 is going to be a large negative number, much larger than minus 1. And that tells us that the pivot column is the y column. Are we happy with that?
Yeah. Good.
Now we work out the theta values, yes? And we get the theta values by dividing. Oh, I put the minus 2m in the wrong place. I do apologize. Let me just move that. So that should be here. Okay, so minus 2m is a value from the equation. It isn't a theta value. Okay, so now we work out the theta values. And I'll change that on the original document. It's probably still a mistake there. So now we take each of the values and divide by the y column. 15 divided by 2 is 7.5. 20 divided by 5 equals 4. 2 divided by 1 is 2. And notice we get exactly the same things as we did when we had the two-phase problem. We will be largely getting the same things all the way through. And if we look at each of those, any negatives or infinite values we ignore. Positive values we look at, we take the smallest positive value, which is the 2, which means that the pivot row is the A1 row. Okay. And just a quick reminder that we label this row S1, this label row S2, because they are the slack variables for the less than or equal to's. For this row here, there's a y greater than or equal to 2. There's an surplus variable and artificial variable. We use only the artificial variable. So that means that x and y and S3 are all 0. Okay, so that means that the pivot row is the A1 row. And in the next tableau, what we're going to want to do is make this row, multiply this row by a number to make this value here a 1. Well, it already is. So we're just going to copy out row A1. And in this column, we're going to try and make the 2 into a 0, the 5 into a 0, and the minus n plus 3 into a 0 by adding multiples of the new row 3, or the old row 3. Before we do so, notice that because the pivot column is the y column, that means that the y will join the basis, so it will replace one of these variables, and the A1 will leave the basis. So that means in the next tableau, this A1 row will become the y row. Okay? Don't change any of the numbers other than the way we said, but the A1 is replaced by y, which basically means that A1 will become 0 and y will become non-zero. So let's move to the next page. And we have that tableau repeated up here, remembering that this is the pivot column and A1 is the pivot row. So now we're going to want to leave this 1 here and make the 2 into a 0, the 5 into a 0, the minus n plus 3 into a 0. How do we do that? Well, for the first row, we're going to take row 3, which is the A1 row, and subtract twice from row 1. That's why I'm writing here in the key, the row 1 is the old row 1. We're going to subtract twice the new row 3, and then row 3 is left alone. For row 2, we have a 5 there, so we're going to take row 2 and subtract 5 times row 3. So row 2 minus 5 times new row 3. And for row P, row 4, we're going to take that row 4, which has a minus n plus 3, and we're going to add n plus 3 times new row 3. So we're going to take n plus 3 times the number 1 and add it to the number minus n plus 3, which will give us the number 0. Okay, so that's the key. That's what we're going to do. But we must do that with each of the cells in each of the rows. So if I just look at row 1, please ignore these ellipses for the moment. So for row 1, we've got an x value of 3. I'm going to subtract twice 0, which is going to leave a 3. For the y column, we have a 2. I'm going to subtract twice the row 3 value of 1, which is going to give us 0. For the S1 column, we have a 1. Subtract twice 0, it's going to leave a 1. For the S2, we have 0. Subtract twice 0, which leaves us with 0. Now for yeah.
Twice 0 minus some at 0 is still 0.
Yeah, that's right. That's right. So for S, are we looking at S1, are we? Yeah, so for S1, we left it alone. 1 times 2 times 0 is 1. For S2, row 1 minus 2 times row 3 means for S2, we have 0. Subtract 2 times 0 leaves us with 0 for S2 here. Yeah. Right, for S3, we have 0, and because we're subtracting twice row 3, we're going to get row 3 contains -1, and if you subtract twice -1, we're going to get 2. For the A1 row, because we're taking that row, subtracting twice row 3, we're going to get 0, subtract twice 1 is going to give us -2. And then for the value 15, subtract twice 2 is going to give us 11. Yeah, and then we do similarly with row 2, subtracting 5 times new row 3. And the one I probably should look at is row 4. So row 4, we're going to take m plus 3 times row 3. So for row 4, we have -1. And if we take m plus 3 times 0 and add it on, we get left with -1. If we have -m plus 3 and we take m plus 3 times 1, we're going to get 0. And then here, we've got 0 in both row 4 and row 3, so that stays as 0. Likewise with S2. Now for row S3, you have to be a bit careful. Might have to do a little bit of algebra on the side. We have m, and we need to subtract m plus 3 times -1, which means that the m's will cancel, and we get just -3. For the A1 column, we're going to have 0, and we're going to subtract m plus 3. So we're adding, we're not subtracting, we're adding. Row 4 plus m plus 3 times row 3. So we have 0 plus m plus 3 times 1 is going to give us m plus 3. Okay. And for values, we're going to take 0 and is that right? What am I doing here? Yeah, what do I get? 6 here. We've got row 4 plus m plus 3 times new row 3. Don't quite see why we got a 6 here. Maybe someone can help me with that. If you can see it, we're adding to row 3. We're adding m plus 3 times row 3. So row 3 had a 2. Oh, because I had the -m in the wrong place. That's why. Okay. So -2m should have been here. Okay. Apologies about that. So I had -2m, and if I add m plus 3 multiplied by 2, I have -2m plus 2 times m plus 3. The m's cancel, and I get 2 times 3, which gives me the 6. I hope that's clearer now. Okay, so apologies about that one. So now we have the values here. And notice that we can read off here the fact that we're at y equals 2, x equals 0, and p equals 6. So we're at precisely this point here. We now work out the theta values. How do we do that? Well, we look at each of the columns in the p row, and then -1 and -3. The highest negative value is the -3, so that becomes the pivot column. We now calculate the theta values by dividing 11 by 2, 5.5, 10 by 5 is 2, 2 by -1 is -2. The smallest positive value is 2, so the pivot row becomes row 2, which is the S2 row, and the pivot value is 5. Okay, that now means that S3 is the pivot column, so S3 is going to join the basis, S3 is going to become non-zero from being 0, and S2 is going to leave the basis. So it means in the next tableau, we're going to replace the S2 row by being an S3 row. So the S3 will move to the beginning of row 2. And if we move there, we have this here, this row here. Oh, yes. Yeah. And what we now do is that we now want to take this pivot row, which is row 2, and we want to divide that row 2 by 5. Okay, so this is where I'm manipulating the rows. Notice that this row heading here was S2 is now an S3, otherwise the same. So row 2, we're going to divide by 5 to make this pivot value, which was a 5, into a 1. So 2 divided by 5 becomes 0.4. The 0 stays as 0, the 0 stays as 0. 1 divided by 5 is 0.2. 5 divided by 5 is 1. Minus 5 divided by 5 is minus 1. And 10 divided by 5 gives us 2. Notice that's the old theta value. And then we look to change the other rows so that the values under S3 that were 2, minus 1, and minus 3 become 0, 0, and 0. How do we do that? Well, we're going to take row 1, which is 2, and subtract twice the new row. Now, the old row 2 was 5, but the new row 2 is 1. So 2 subtract 2 lots of 1 means we take row 1 from the old tableau and subtract twice new row 2 to get the new row 1. Okay, that's a bit of a mouthful. Let's just do that bit and see that it works. So row 1 under the X, we had a 3, and we're going to subtract 5 times. Oh, wait a minute. No, twice, yeah, because this value here is a 1, row 1 is a 2, so we want to take row 1 and subtract twice new row 2. So if we do that, row 1 contains a 3, new row 2 contains a 0.4, so we're going to take 3 and subtract twice 0.4 to get 2.2, because 3 take away 0.8 is 2.2. And now 0 take away twice 0 is 0. 1 take away twice 0 is 0. And now here, for the S2, we have 0. Take away twice 0.2 is minus 0.4. And then for this column where we want to make all the zeros, we have 2. Take away twice 1, going to give us 0. Where we have minus 2, if we take away twice minus 1, we have minus 2 plus 2 is going to be 0. And then for the value 11, take away twice 2 is going to be 7. And we do the same thing for each of the other rows. For row P, we can see that we have a minus 3, so we're going to have to add row 4, we're going to have to add 3 times new row 2. And if you do that, you get these values here. Okay. And what you notice, I hope, is that the values here are all positive. Okay, so we have 0.2 under X, 0.6 under S2. We have a large positive number under A1, and so we can't increase P because there's no negative values here that we can proceed from. And so we are actually at 0.4. How can we see that? Well, we can read the values. So the things that are not in the basis are 0. So X is 0. So when the X equals 0, that's the Y-axis. Y equals 4. The other coefficients other than under the Y are all 0. So effectively, this reads as Y is 4. And P is 12. So we know we're at X is 0, Y is 4, P is 12. If you want any of the other values, you can read them from here, because S1 will be 7, S3 will be 2, and so on. Okay, and so we finished example 1 from the bigM method. I'm going to stop